provide a lot of things. Sometimes I read some papers.
No problem.
I will never use that. It's not for me. It's far from what I'm doing. And that sometimes is hard because you have a very good man, a very good person, and or woman, and it doesn't even fit for your business. So what's the point to keep? The right methodology, that's another problem we found, and it's a very big problem. How we make a data science project going efficiently, and make sure that it has the right step. That's hard because there is no clear methodology in data science, where we should start, where we should begin. So again, I will bring some not a good example to start with, and after that I will show you how we do in my company. So there is a business company who started last year again, showing their methodology and what they do. It's a positive company, so they have lot of experience in different things. And what is very interesting is that they starting with data. So the first key thing they ask when they enter the company is okay, let's start with the data. Okay, anyway. And after that, they get the question, the business question, what they want to achieve. And again, they need IT expertise to get the right data to do that project. So again, there is no link between data science and the IT side. And she shared the slide, and she said a lot of examples where there is no fit, and data science are stronger to get the data, the right data to the IT people. Where in my team, this kind of thing never happened. And you should not start data anyway. So, the first thing to do when we starting a data science, if we got the right business problem, to start to explore the data. This is something very interesting when we explore the data, because we find sometimes some pattern. Sometimes it's just enough. By exploring the data, you find something already, some insight. So yesterday in the breakout session, we have a subject about data quality. And then someone said, yeah, you need to have the right data quality before starting machine learning model, etc., etc. Yes, but sometimes bad data quality is good to know, because it's also an enabler to analyze, it's an enabler to create a data science on top of it, and you understand if there is a pattern in your business. Bad data quality is good to analyze also. Anyway. So for instance here, you have people who don't know the sex, some customers, so what's happened to them? Are they profitable? Are they complaining more, etc.? So that's something very interesting to probably create a business case behind this data quality problem. After that, we talk about feature engineering in the first time with Gartner. So what is feature engineering? So this is a trend. This is probably it was the heart of machine learning. I would say 2-3 years ago. So what is feature engineering? It is to make a machine more intelligent. So let's imagine you have a lot of features in data, and you want to make the machine more intelligent about the feature. Sometimes the machine needs to be understanding the feature better. So it's a way to feature engineering to create a new feature on top of your feature. For instance, colors. Make understanding machine like pink, purple, yellow colors is more big for women. So there is someone in a Kaggle. Anyone knows Kaggle? Yeah? So Andrew Fox won the competition just by using better feature engineering than the others. By collecting the cars, the data of the cars with atypical colors and make your machine more understandable. That was the past. So I will now starting to go more deeper in machine learning. So how have we lost anyone? So my challenge now in my case is to make everyone loving machine learning by using some maths. I said it's a challenge, I didn't say I will succeed. So last month again, there is someone in the said, what's the point? Machine learning now is a big buzzword. we did that 25 years ago. Yes, it's true. But in machine learning also there is a trend. It's not because we done that 25 years ago that that's stopped. It has changed a lot, and it keeps changing, and it keeps evolving. So here, something very interesting is XGBoost. So, if you see the Kaggle competition, if you are a fan of Kaggle, go there, and you will see that the most people who are using Kaggle are using one model. Only one. It has been introduced 2 years ago. And it's the way we are now fast computing, we are using GPU, etc. It's amazing because it can pass data. Okay? A lot of people say maybe it's black box, it's not, I understand why. But this is a that you need to keep your eyes on the technique you watch. I know only that. We change our old model, random forest, to that. It's increasing a lot of forecasting. It's increasing a lot of accuracy. So XGBoost is a random booster model. So I'm trying to explain that. This is my challenge to explain what is a random booster model in machine learning. In math. In 5 minutes. Yeah. I don't need 5 minutes to make you all understand. So let's imagine you have, we switch up already. Let's imagine you have something to predict, like what you want, churn or whatever. So it's a variable y you want to predict. So Random Boosting, what it's doing is just creating a model, a mathematical model with all the features you have. Then you have the customer's age, the customer location, the consumption, etc. All the features is X. And you're using a model to predict the Y. But every model has a percentage of error, so it has an error. What he's doing in this model, he said, okay, but this error, it could be also depending on the other variable. So my error, I will try to find another model, I will say N, okay, to find if I can find a trend in my input and go to error 2. I have another error. And after that, he's doing again. And he tries to find another model. And because it's a fast computing, he can do that, etc., etc., etc. So the error, what's happened? So after that, everything is great. Thank you very much. And yes, that's okay. So after that, everything's great. But after that, we want to minimize the error. So the error is going thinner and thinner and thinner and thinner. That's what we want to do when we are doing machine learning, to minimize the error. So what's happened at the end is that my y is equal after that we use a weight, so equal alpha mx plus beta and blah blah blah. And it has a minimum error. Everyone understand that? That's how it works. It's easy to understand. The thing is, if you are doing that, a lot of people ask me that why we don't arrive at the end error equals 0. I said we should not have error at the end equals 0, because if you do that, what it means? That means you are overfitting. You mean what means overfitting is about your model is too much on your data, too much data on your data. And this data, again, it's not it's data, but it's not the real data at the end, because it's your test data. So you should not have a model sticking on this data. You should be understanding all the right data. So if you have an error at this stage, 0, that's crap. It will never work. So how to avoid overfitting in 3 minutes? Cross-validation. So cross-validation is easy. You have the data, you try to test on the blocks. You split that into 5 blocks, for instance. Cross-validation by 5. You take 4 blocks, you run that, and you test in your other blocks. And you switch the blocks and see if the error rate is the same. And to make sure that your model is not overfitting or even underfitting if you have less data. I will be quick. It's not my fault, it's the previous one. The thing also in the methodology that is completely missing in a lot of project data science is the feedback loop. So because we are in the data, we know that the data is going live, it's going to change, etc. The model could decrease in the performance. So we need to have a feedback loop to understand how it works. I saw some people doing some machine learning after that. Oh, okay, good, I did that, I'm doing some other project. Yes, but you need to build that. For me, a machine learning project is like a baby. If you have a baby, you never let him like that and see you in 2 years. No, you have to take care, you have to feed him, etc. So that's something also missing. So I like the rabbit hole thing. So this is again something problematic in machine learning. You are sometimes getting, oh, you can do that, oh, add that, oh, try that, oh, etc., etc. And I found a lot of projects taking like 6 months and nothing going live. So because we are using now XGBoost, because we have the right model, because we have the right mindset, in my team we are going very fast. So we are doing sprints, and I'm pushing my team to do sprints every week. The first time I introduced that in my team, it was like, what? Yes, we can do that. But let's iterate in different versions. Let's go fast. Let's deliver, let's deliver, let's deliver. And we are doing the sprint every week. We deliver something every week. And that's the right thing to do because we can go fast and we can deliver something. Even if it's not the data we want, because we want to use another data, because we want to improve the model. Oh, I'm not happy of the accuracy of my model. Yes, let's go. It's the first input. It could enable the first decision in the business. It could give you the first results. It's not perfect, but let's go fast. We are in the business. People invest in us. We need to create value. I'm just finished with that. The new trend coming is about automatic intelligence. So data scientists are, I think, also being really changed a lot in the next few years, and we have a lot of tools are doing that now more automatically. So it's not me, it's Gartner said that. Again, automation is going fast, even in data science. So for me, the gain efficiency is what we saw in the past. If you are in the BI sphere, you remember when we were scraping, we are doing that in SQL, and we had the ETL like 20 years ago. And now it's doing the same. So people are using R and Python in data science. I think in 5 years, it will change everything. So we have that IQ in the stands, who is a good tool to doing that. But there is a few tools also in doing that. Again, the Elofin who has embraced data science in the tool. And also a very good tool I think you need to look at is also Datamine, who is trying to automatize everything also in the tool. So it's getting fast in there. So don't be scared. There's some tools that can help us to getting fast. And at the end, the team. So I like this sentence yesterday morning, say data scientist has all these skills, so it's not possible. Yes, maybe it's not possible, but how we can tackle that? We can tackle that with the team. So I like this tool. If you see bsquadra.com, they can map you with a few questions. What is the level of skills in the team? So where is your strength, where is your weakness, and you can improve your team like that. And that's three people in my team, and you can see where you are good and where is missing, what the capability is missing in your team. And that's the way to create the data scientist team. I think I finished on time. Thank you very much. No, that's okay.
So I told you it would be exclusive. We have a client play, and we have two
Yeah. So deep learning is very interesting when you go to a lot of data. So we are using a little bit deep learning inside my team. So deep learning is convolutional neural network. Again, I think there is already some very good project done mostly in the image side when you want to compute images. But we have some interesting subject about the voice also by using deep learning. We did some tests in time series also. I did comparing machine learning classical with deep learning. If you don't have lots of data, I can show you that machine learning is taking better than deep learning. You need to be careful of which technology you are using. But for me, the next trend of AI is not deep learning. I don't know if you heard about reinforcement learning, which is growing fast. If you want to talk about after the break about it, I'm happy to talk about it. Can you see if someone is using decreasing matters, what do you mean in the real life? Or not understand? So, yeah, this decreases is rather that's introduced how it goes internally. So we don't see all the stage. So introduce is working like that and give you the right errors. So you don't see all the steps. All the steps I've described is just to give you how it works. And no, you will take the best one. Yeah, obviously.
We'll discuss that later. All right, thank you. That was, we're all experts in machine learning. Very much.
Thank you very much.
Nevertheless, we'll press on with, we're going to have a panel now. Can I invite the members to come up, please? So we have David Naylor, who's Head of Market and Business Intelligence at the NAF Institution, Ben Dias, who's Advanced Analytics and Data Science at the Royal Mail, and Norman Stewart, who works for Credit Suisse. Gentlemen.